Good afternoon, everyone. We'll give folks a minute or two to make their way from the waiting room into the webinar. Welcome to the talk today, Hurricane Ecology, Understanding Risk and Planning for the Future of Longleaf Pine. I'm Karen Brown with the Longleaf Alliance, and we are very happy to have Nicole Zampieri with us to take us through her work and her colleagues' work on this subject. It's a very timely one indeed, as we in the southeastern U.S. are still in the midst of a busy hurricane season. Nicole is a research scientist with posts at both Tall Timbers Research Station and the Jones Center at Ichauway. So before I turn things over to you, Nicole, I just have a couple words about the format today itself. We really encourage all of you joining us to add your questions into the Q&A function, which is at the bottom toolbar of your Zoom window. Add those throughout the talk as things come to you, and we'll address them towards the end of the session today as time allows. We'd also like you to introduce yourself. Use the chat function for that. We'd love to see who's here and where you're from. I'd also like to introduce Cody Pope with the Longleaf Alliance. Cody will be helping to moderate those portions of the webinar today. So he'll be working in the background with us during the duration. Nicole, so at this point, it'd be great to have you take over control of the screen and begin when you're ready.
All right, I am ready. So thanks to everyone who's in attendance, and thanks to Karen and the Longleaf Alliance for asking me to present today. As Karen said, my name is Nicole Zampieri, and I'm a postdoc at Tall Timbers and the Jones Center at Ichauway. My research broadly examines how disturbances like fire and cyclones affect longleaf pine population dynamics like growth, establishment, and mortality. And in my talk today, I'll review hurricane ecology, discuss risk across extant longleaf pine and how risk varies. And last, we'll provide suggestions for adaptive management of longleaf pine under threat of increased cyclone activity. And I'll note that this project is a collaboration between myself and my colleagues, Jeff Cannon, Bill Platt, Christine Fortune, Frank Gilliam, and Ajay Sharma. And this is still being developed, so I look forward to your feedback at the end. So cyclones are globally common and frequently affect coastal ecosystems. These ecosystems face worldwide declines due to growing pressures such as population growth, land use change, sea level rise, and drought. And I'm sure all of you here today are well aware of the many threats faced here in the coastal plain. Cyclones further complicate these issues and pose a complex challenge for conservation in affected areas, slowing down restoration progress and reducing overall extant habitat in extreme scenarios. You may have noticed that here in the US, the majority of hurricane impacts are within the Southeast. In this main figure presented here, I've presented just category 1 through 5 storms from 1950 through 2020. And that's because when we plot the entire record, which is at the top right here, it kind of becomes impossible to see anything. And so this is the record from 1851 to 2020. So we can all see that hurricanes' impacts in the US are largely restricted to the coastal plain, the southeastern region. And I'll take that a step further and suggest that the occurrence of hurricanes is notably correlated with the North American coastal plain biodiversity hotspot. The longleaf pine ecosystem is incredible in terms of the number of species it hosts, with levels similar to that of a tropical rainforest. The biodiversity here is in part a product of the hyper-frequent disturbance regime, largely in the form of fire, but it's very likely that the history of frequent hurricanes, especially when you consider interactions with fire, played a major role in shaping current structure, function, and diversity that we see in the coastal plain. However, not much is known about the evolutionary role that cyclones have played on ecosystem dynamics, and hurricanes have largely been thought of as sort of a background process in these systems. Recent work by Jeff Cannon describes 4 distinct hurricane regimes experienced by ecosystems in North America based on wind speeds and the frequency of occurrence. So the idea here was to characterize this disturbance regime the same way we think about fire. So for example, we know fire historically occurred in Longleaf from 1 to 3 years at the most frequent, while in some areas it may be more like 3 to 5 years. Here, what we found, what Jeff found in this work, was that hurricane regimes of North America can be classified as fringe, coastal, inland, and continental, which experience tropical storm force winds anywhere from 4 to 6 years in the fringe, coastal, and inland regimes, while the continental regime experiences a 94-year return interval. So at any location within these regimes, you can expect to experience tropical storm force winds at these intervals. We actually know little about the hurricane ecology of these systems. Most research on hurricane impacts to these ecosystems focuses on the effects of extreme events or where hurricanes make landfall. But these less extreme high wind events like tropical storms or wind from hurricanes that make landfall and then weaken as they pass through the continent have flown under the radar as a significant component of the ecology of these systems. In addition to a lack of attention to chronic, inconspicuous high wind events, like many systems in the East, we lack a complete understanding of hurricane effects and ecology because of widespread degradation and loss of habitat in the coastal plain. There just isn't that much left to go off of, especially, high quality habitat in pre-colonization conditions. Colonization, fire exclusion, and continued anthropogenic stressors have reduced this system to a fraction. So what do we know about hurricane ecology? The cyclone effects are numerous ecologically. So first of all, we know storm surge. Storm surge may affect as far inland as 40 kilometers. The coastal plain is also karst, which means it's porous and susceptible to saltwater intrusion. High wind generates mortality and augments population structure, so recurrent cyclones may be an underappreciated source of recurrent mortality, contributing to open canopy conditions and creating habitat heterogeneity by constantly downing trees. Primary demographic characteristics of tree growth and reproduction are also affected by cyclones. In instances where mortality is very high, the surviving trees may experience growth releases. But in the majority of lower intensity events, widespread but non-lethal injury and damage may generate stand-wide suppression events. Down trees also increase light to the understory and create favorable patches for regeneration. And masting, which is a main driver of recruitment in Longleaf, may be stimulated by the passage of a cyclone. Lastly, there are numerous interactions with fire. Region-wide needle casts from a cyclone would have naturally led to more intense fires in the following year, landscape-wide. And we know debris and downed trees affect fine-scale fire behavior and create a heterogeneous fuel bed. Now, although hurricanes have long been a part of the ecology of these systems, evidence suggests that hurricane regimes are changing. Major factors leading to tropical cyclogenesis, such as high sea surface temperatures and humidity, have increased in recent decades due to global warming. This figure shows the average number of storms per year by decade from the 1850s through 2010s that shows the number of cyclones per year has increased. Further, evidence shows that storms are increasing in intensity and experiencing much faster rates of intensification. Thus, increasingly strong storms, coupled with the lack of remaining habitat, are what pose a threat to the coastal plain. For an example, I'll showcase a case study of some of my own findings from studying the effects of Hurricane Michael, which was an extreme tropical cyclone. Michael made landfall in the Florida Panhandle in October of 2018. It was the first Category 5 to make landfall in this area in recorded history, and is one of the strongest hurricanes to ever make landfall in the US to date. I studied the effects of Hurricane Michael across a few sites of longleaf pine in the Florida Panhandle. I overlaid the Florida longleaf pine geodatabase and the known wind extent of Hurricane Michael, and I was able to estimate that at least 28% of the global extent of longleaf pine habitat was affected in Florida alone. The storm had a huge breadth and it traveled north through the remaining coastal plain states. So really, this is a conservative value and goes to show how one storm can affect nearly the entire range of longleaf pine. In my research, I also estimated hurricane-induced mortality across these sites, which vary in distance to the storm center. The storm track is on this map in that black and white dashed line. You can see it made landfall near Mexico Beach in Florida and then proceeded northeast. Looking at trends in mortality, overall, we found that mortality increased with decreasing distance to the storm center. So it was highest by the storm center. At the sites furthest away, we had 4.6 and 7.4% mortality. And at the sites closer, we had 15% mortality, up to a maximum of 88% mortality at the site that was within the eye wall of the storm. When looking at trends in mortality by size class, I found that mortality varied by size class and was actually highest in the medium-sized trees, as high as 98% at the site within the eye wall. That's Appalachia WMA at the top left. That site showcases a real critical vulnerability that sites along the path of the eye wall in these extreme hurricanes are at significant risk of total state change, even 100 kilometers inland. Furthermore, I found that post-hurricane management responses exacerbated storm impacts in some cases, with the potential for virtual extirpations of populations of trees and sensitive understory plants related to salvage logging operations. After a hurricane, historically or naturally, there's a large amount of down and dead woody debris. And without human intervention, this would have created complex interactions between lightning and fire in the following years, leading to potentially high severity fires. But this is how the system evolved, and it would have been part of the natural cycle of recovery. Today, we all know ecosystems in the Southeast are so fragmented and surrounded by human infrastructure that we have to suppress wildfires. And this includes removing down woody debris after storms to reduce the risk of extreme wildfire. Unfortunately, this process is often extremely intensive and can dramatically alter the understory, which is what drives the majority of ecosystem function in these communities. You know, all that biodiversity that Longleaf is so known for is largely restricted to that very sensitive understory. After an event like Hurricane Michael, what we found here was that the region was saturated with a need for help, and managers were forced to make sort of rushed and often piecewise decisions with very limited resources. And I understand that this is a huge problem, that most of the time people wanted to do what was right and what was best, but there was not enough time or people or money to do it right. In Florida, what we saw was this sometimes resulted in contracting out to external partners coming at times from very far away with little knowledge of ecosystems and management goals, and a lack of recognition for the importance of the understory and preserving the understory biodiversity. Some of the resulting management actions included salvage logging, clear cutting and thinning, and then most damaging ground scraping and debris piling and burning. These actions collectively reduce understory biodiversity and create soil damage that extends recovery time from decades to hundreds of years. In the pictures here, you can see dramatic effects of these actions at a site in Florida. So this photo is taken at the same site in 2019, immediately post Hurricane Michael. You can see the damage on the site. 2020 is post-salvage operations, which included some sort of ground scraping and burning. And then 2021, post-salvage, a year post-salvage, you see sort of weedy successional species moving in and invasive species moving in. So it's not just that hurricanes are increasing alone, but it's these combined stressors of compound human impacts post-storm that particularly threaten this ecosystem. So seeing the devastation post-Michael and what followed motivated myself and my colleagues to identify what exactly is at risk and how does risk vary across the range of longleaf pine. And further, we propose adaptive management strategies in the face of changing hurricane regimes to answer how can we prepare and manage for cyclones. We define tropical cyclone risk as the probability of change in ecosystem structure and function related to high tree mortality and impacts on ground layer composition and diversity that are associated with a tropical cyclone. We wanted to know how much existing longleaf habitat there is, where it's located, and how does it classify along this gradient of hurricane regimes. So using the Southeast Longleaf Pine Geodatabase, which is a product put together by the Florida Natural Areas Inventory with the Longleaf Alliance and America's Longleaf Restoration Initiative. This geodatabase provides the most comprehensive information on current existing longleaf pine. So we overlaid this with the North American hurricane regimes. And here's what we found. Of total extant longleaf pine, the majority is in the inland regime. So that's 86% or 1.7 million hectares is within the inland regime. This regime experiences tropical storm force winds every 6 years and will experience category 1 force winds every 200 years. 12% is in the coastal regime, so that's about 250,000 hectares, which will experience tropical storm force winds every 4 years and at least category 1 force winds every 30 years. 2% is in the continental regime, so that's 38,000 hectares. Exposure risk here is very low, but it's not nothing. And you can expect tropical storm force winds about every 100 years. In the continental, I don't know if I said the right word. Now, across this gradient of hurricane exposure, risk varies based on a system's capacity for resistance and resilience. Resistance is the ability of a system to not change substantially in function or structure in response to a disturbance, so to withstand any effects. Resilience is the capacity to recover to pre-disturbance conditions after substantial changes due to a disturbance. So in resilience, trees may fall, trees may die, but regeneration is able to occur and the ecosystem is able to continue. These ecosystems naturally have some capacity for resistance and resiliency. At various scales, different factors contribute to a system's resistance and resilience to high wind. At the broadest scale, so regionally, atmospheric conditions contribute to individual storm characteristics, wind speed, storm path, storm surge, saltwater intrusion, these kind of things. At the landscape level, factors like topography, forest edge orientation, and soil type affect risk. These characteristics are largely determined by sort of biogeographic history, but also have influence from past land use and disturbance history. And then at the stand level, human management actions and decisions really come into play. Species vary in their wind firmness and ability to withstand disturbance or to resist, and then to regenerate afterwards or to be resilient. Structurally, a more diverse stand structure of different ages and sizes is going to be more resistant and resilient as different classes vary in their vulnerability and may provide insurance. A history of frequent fire ahead of a disturbance also plays a key role in developing that resistant and resilient structure and function. Across the coastal plain, the landscape and stand levels have been altered dramatically, and characteristics within vary based on disturbance history, such as fire exclusion, as well as ownership and management goals. Within stands, the community components face unique risks from cyclone effects. Individual trees vary in their susceptibility to high wind based on genetic traits, size, and location within a stand. A really important trait is height and taper. So that's the ratio of diameter to height, with shorter and wider trees being more resistant, more able to withstand wind. Crown architecture is also important here as influencing wind drag. Talking about faunal communities, especially endangered species like the RCW pictured here, are affected by changes in forest structure, loss of habitat, and complicated fire effects. And then last, the understory flora is largely forgotten about in this conversation around resistance and resilience, but we know is super important in the coastal plain. Resistance and resilience is higher with grass continuity and species diversity, which will burn and rebound more quickly. Main risks brought by cyclones are soil disturbance, changes in light availability, introduction of invasive species, fire effects, and then post-cyclone salvage operations. Beyond those scaled risk factors, linked disturbances affect risk. So these are sort of second-order effects that interact with post-cyclone stand conditions that may further exacerbate risk. First is post-storm fire. Fire may increase mortality due to a number of interactions. For example, the crowns of downed trees may burn more intensely, damaging and killing nearby trees. Drought and other climatic conditions may impede recovery of the understory and trees and may compound mortality by reducing this capacity for recovery. Insect outbreaks may be a problem where there is mass mortality. While longleaf pine are generally resistant to a variety of pests, more frequent mass mortality events may create conditions more conducive to insect outbreaks. And salvage logging operations. These operations are common for a variety of reasons. Some is to recover lost value for timber and or to reduce second order effects like insects and fires. But these operations can damage the understory and impair natural vegetation recovery, can compact the soil and facilitate erosion, can encourage colonization of non-native and invasive species, alter nutrient cycling. It reduces fire and light refugia created by down debris, among other effects. With any one of these linked disturbances, it's worth noting that the fact that these are compound disturbances of a hurricane followed by one of these events that may contribute to negative ecosystem outcomes. It's the doubling up that may lead to consequences for species who may be unable to withstand two severe disturbances in very quick succession. Considering how all of these factors contribute to risk by affecting a system's resistance and resiliency, we can look a little further into what is at risk beyond sort of the geographic probability of wind exposure and consider who is managing these systems and how are they shaping them in ways that affect risk. First, just geographically, where is it? The majority of extant longleaf pine is in Florida, followed by Georgia. The majority is also classified as natural, while 24% is planted. About 20% is unknown here. Now, natural stands may suggest a more uneven age structure, which increases resistance and resiliency, but that's not always the case. And now considering ownership, these different agencies and owners have different land use histories, management goals, and priorities that perpetuate systems that vary in their vulnerability. For example, a private landowner managing for timber production may have more densely planted younger pines than someone managing for restoration of old growth attributes. And here, worth noting when we talk about ownership, that nearly 40% of all extant longleaf pine is in private ownership. And thus, if our goal is to collectively preserve and restore as much habitat as possible, we have to consider how to support private landowners in reducing their risk by enhancing resistance, resiliency, and our response. Now, breaking these stats down by regime, so these individual percentages here still represent percentages of total longleaf pine. And I'd like to look at the two sort of dominant regimes, inland and coastal. Looking at the inland regime where 86% is found, 86% of total longleaf is found, this regime experiences tropical storm force winds every 6 years. And it is mostly in private ownership. So it's 34% of total longleaf in private ownership within the inland regime. Now, within the coastal regime, where risk is the highest, 12% of total longleaf is in the coastal regime. This experiences tropical storm force winds every 4 years. The majority here is managed federally. That's about 7% of total longleaf. And this number is largely due to this large continuous swath of habitat in the western panhandle of Florida from parts of Eglin Air Force Base and the ANF that are in this coastal regime of higher risk. So how do we move forward? We plan for cyclones and consider adaptive management under changing regimes. Planning includes anticipatory preemptive actions that promote and maintain systems that are resistant and resilient, and having response plans in place to deal with immediate impacts to reduce rushed or malformed decisions. Preemptive anticipatory actions may vary based on overall management goals. There are two major sort of paradigms or management goals or perspectives. The first is the conservation or restoration management for biodiversity, function, or old growth attributes. And the second is a focus primarily on sustainable harvest management. Where the goal is sustainable harvest management, silvicultural operations can be altered based to produce stands that are resistant and resilient to wind throw. These strategies include careful selection of planting sites, species, and the timing of activities. Also, planting at lower densities or frequent thinning to encourage trees with that lower height to diameter ratio. This encourages greater wind exposure through the tree's lifespan through that thinning, and may increase their ability to withstand high wind by encouraging that sort of shorter, wider stature. Planting at different intervals to facilitate greater age and structural diversity, and thus mimicking old growth stands. And then planting for intra and interspecies genetic diversity whenever possible also helps to provide that sort of insurance policy. Where the goal is conservation and restoration of biodiversity or old growth attributes, pre-storm management strategies include developing prescribed fire management programs that reinstitute frequent and lightning season landscape level fires, conserving ground layer vegetation and microbial communities that function to recycle nutrients and promote frequent landscape level fires, again. And the third is conversion of these even aged and sized and sometimes very dense stands of pines to uneven aged and sized lower density stands in which natural recruitment can occur. Well, 1 and 2 are not directly related to the effects of cyclones here. They are what historically encouraged the diversity that promotes resilience and resistance. And across goals, structural diversity contributes to resistance and resilience, since different sizes and ages vary in their vulnerability to wind and to linked disturbances. Now, across all levels of planning, beyond taking preemptive actions, we need to develop response plans. And these should detail guidelines for rapid assessment that quantifies and ranks losses of different values to inform recovery prioritization. For example, economic losses due to timber loss and ecological losses due to damage in sensitive habitats carry different weight and will require different interventions depending on the overall management goal. Planning should include pre-planning for information exchange among stakeholders. These individual storms generate regional scale impacts, and coordination, communication, and resource sharing that crosses jurisdictions. And consideration for private landowners is essential. Identifying key stakeholders in the pre-planning process who can best facilitate the exchange of information will be an important component of hurricane response plans. I've skipped over salvage logging decision guidelines, but I'll go back to it. The last in this list about responding to future cyclones is post-storm monitoring. Post-storm monitoring for years is important for evaluating recovery and adjusting management actions. While there are many immediate and obvious impacts from cyclones, others may take years to realize or be less obvious. For example, invasive species may take time to colonize. Regeneration capacity of canopy trees may take a few years. Delayed mortality of overstory trees may occur for a variety of reasons. Beetle outbreaks may take 1 to 5 years. That's all to say post-storm monitoring can ensure that management actions can be changed if needed to meet goals. So back to salvage logging. Plans need to detail whether to and how to intervene through salvage logging dependent on overall management goal. Earlier in this presentation, I showed you some devastating photos from a site that was basically completely clear-cut and scraped in a salvage logging operation. Here are some photos from a different site after Hurricane Michael. The left panel shows aerial photos and the right shows corresponding field photos. As pictured, you can see misguided salvage operations can be devastating to an ecosystem. The first panel shows about 6 months pre-storm. You could see the state of that stand. The second row shows 2 days post-storm. We had aerial imagery and field photos there that show storm damage. And then the last is 1 year post-storm. And at some point in between these photos and the last storm, there was salvage logging operations done here. I'll note in the bottom left aerial after salvage logging, the soil disturbance is tremendous. You can see all those 2 tracks. And I know from working at the site 1 year post-storm, many of the rare plants from the site were extirpated. Wiregrass was destroyed. There's virtually no mature trees left. And so this site now lacks a seed source and it lacks fuel continuity and will require further intervention to restore. So managers need to consider if salvage operations are necessary at all. And there's a few things that go into that. One is being able to better estimate the risk of these linked disturbances, such as insects or wildfire, is a crucial next step for research that would inform the urgency of salvage operations. When risk is low, there are actually many ecological benefits of leaving dead trees and down woody debris on site. This down woody debris and logs and snags provide habitat for numerous organisms, especially invertebrates, but also woodpeckers. They facilitate nutrient cycling through decomposition. They create that habitat heterogeneity and fuel heterogeneity. and they provide fire refugia for seedling establishment. And then I'll reiterate again, retaining the intact functioning understory and the soil is hugely important for conservation in the coastal plain. So back to planning and considering salvage logging and planning. Plans should include salvage logging decision workflows based on managers' goals and objectives, and should consider what are the primary motivating factors for salvage? And is it about reducing risk, or is it purely for a financial incentive? There are some existing methods and guidance for making salvage decisions based on the type of individual tree damage and the potential for timber value recovery, which is not always profitable because of oversaturation of the market after an event like this. The second is to determine what are the risks of those linked disturbances, compare actions and outcomes with management goals. So if your management goals are related to biodiversity or restoration, stand-wide salvage logging may be incongruent. Consider, are there lower impact options, such as limiting ground-based logging? Consider exclusions to salvage harvest. For example, where known rare species occur, or set areas aside just to retain some of that downwoody debris. And then lastly, when necessary, follow ecologically defensible salvage policy. Lindenmeyer and Noss in 2006 provide recommendations for what they call ecologically defensible salvage policy that have applications for ecosystems across the coastal plain. These include designated areas be completely excluded from salvage operations, overall limits to salvage quantities, consideration for understory phenology and the timing of operations to reduce impact, and then severe limitation to ground-based logging that destroys the soil and the understory. So that concludes the meat of my talk, and I will leave you with some brief conclusions. Future cyclones are inevitable and avoidable. Adaptive management, regardless of ownership and overall goals, can promote systems that are resilient and resistant to future cyclones. And further, anticipatory planning can ensure that our response facilitates recovery of critical ecosystems. So thanks for your time. I will be at the Longleaf conference next month in Sandestin. So I put that flyer up there. Hope to see many of you there. And here I've linked, I've put some QR codes and references with some of those relevant citations and things I mentioned throughout the talk. And I've also put my email on here so you can contact me privately that way. And other than that, I think now we have time for questions. So that's all I have.
Thanks, Nicole. That was great. And if you don't mind, I'll link these papers to the webinar page so that if folks don't grab them here, they can always return to the webinar portal where you began today and find those resources. Yeah, that was a great talk. I think I was coming up with questions, but then you would answer them a slide or two later. So which is just an excellent way to cover such a really thought-provoking topic. I did have one offline though about that salvage question. Foregoing salvage post-storm, to choose to forego that would be quite a big paradigm shift for how things are normally done. The economics of selling your timber in a post-storm marketplace is usually pretty poor. The market's flooded with everyone trying to sell this very low quality products, just due to the breakage of tree limbs and tree boles. So I wonder, and this is probably a question without an answer, but I wonder if there's an opportunity for another type of paradigm shift to maybe have a kind of deferral type of payment to forego that salvage operation, kind of landowners being incentivized to leave some of that downwoody debris to avoid some of that other ecosystem damage. Just a thought. I don't know if you've encountered that topic in your work or see that as a kind of a new frontier to take this subject matter.
Right. Yeah. So let me be clear. I'm not advocating for no salvage logging. I do understand that we need some amount of salvage. And really that my emphasis on it is that it should be reconsidered and done carefully.
Sure.
But yeah, so a part of this work is really to put the onus on the government, the federal government and state governments, and policy in order to help landowners out in making these decisions. And something like what you just described, I think would be an excellent way to do that while managing for other issues like the risk of a fire and et cetera, which I am aware of.
Mm-hmm. Sure. Yeah. An evaluation needs to take place and kind of for total volume and evaluating those risks. But something different than some of the kind of business as usual responses that we tend to see.
Mm-hmm.
So we've got some questions in the chat I can bring up now. One from Olivia DeGrenia. They ask, do you think heat stress would also make longleaf pine trees more susceptible to mortality following a hurricane?
Heat stress, as in climatic heat stress, I presume? The answer is yes. Climatically, longleaf pine are sensitive to summer maximum temperatures. And that story is actually a little bit complicated because as long as there's enough precipitation, usually the trees do fine. But if there's not enough precipitation and that heat stress turns into drought stress, that is when the trees can do poorly. And so that would be an example of one of those linked disturbances. That's a climatic linked disturbance there where we may have more mortality than otherwise with that compound disturbance.
Right, and with the changing climate, that's just going to be even harder to predict. Thank you. All right, we got another one from Kent Salisbury. Are there those persons whom are actively planting and recruiting acreage for longleaf pine's success and resilience?
I presume this question is about broadly across longleaf pine landowners, and I would say yes, that is, those are major management goals right now, planning for resistance and resilience in longleaf planting, and that is the time to start thinking about it and planting to maintain that age and structural diversity, planting at different time intervals. I hope that people are out there actively doing this.
Yeah, definitely one of the considerations people need to start taking into account. Okay, we got another one from Ryan Bollinger. He says, thank you, Nicole, for an amazing presentation. Under America's Longleaf, the Federal Coordinating Committee and Longleaf Partnership Council, meeting prior to the Longleaf Conference, they're great forums for addressing issues and taking actions. What strategies from your presentation could be a fit for these regional groups to help address?
Sure. So the biggest thing I think for these regional groups, which are great, are for facilitating information exchange. And I have highlighted that as a major priority in the pre-planning process. These organizations would be great places in these meetings to put together these resources to get to landowners at in their time of needs. And this is goes into the pre-planning process. This should be happening now because when a storm comes, we don't have that much notice. It happens, it hits, we have all this impact, and then landowners are stressed, don't know who to talk to, don't know who to ask, don't know where to go, don't know what resources they have. And these types of meetings and organizations can preempt that and put together those resources.
Yeah, that's a very good point. These groups that already have this overarching reach would be a great place to start.
Mm-hmm.
Okay, so another one from Russ Weber. To increase the longleaf habitat recovery the vast majority of landowners plant, the seedling source found today is open pollinated and is racked with fusiform and forking in my own experience. The longleaf stakeholders need to promote genetics which will limit storm damage from wind. So I guess more of a comment. Would you like to add anything?
Yeah, no, I'll just say that I agree, and promoting genetic diversity is one of the strategies that we're pushing forward on this, and making sure that you are trying to use different seed sources to enhance that genetic diversity.
Good deal. And we've got one more from Andrew Carlo. FSC certification for plantations requires certificate holders to use science-based information on the regional disturbance regime. It sounds like you see disturbances ranging from scattered trees to near complete blowdown / damage and mortality. Is there any resource that describes the extent, area, or acres of the near complete disturbances? Thank you very much.
I don't know of any existing resource that describes total acreage of these near complete disturbances. I presume you're talking about like, so in my research that I presented earlier in this about Hurricane Michael, you know, we saw 88% mortality at the sites along the storm path. There's definitely, after these events, there's always all these estimations that come out, particularly about looking at the valuation of what was lost to the timber resources. But I'm not sure of any existing resources that describe total extent on an event basis.
All right, thank you. So that's everything we have in the Q&A function. If anyone else has any questions, please feel free to put them in there.
Awesome. Well, I just wanted to, in closing, thank you, Nicole Zampieri, for sharing your work. And thanks to Tall Timbers and the Jones Center for supporting it. And I'd also like to thank the Wade Research Foundation for sponsoring today's webinar. Before we go, I just wanted to highlight that the Longleaf Alliance has another webinar coming up next week. Bear with me just a second. That can be found on forestry webinars as well. The topic of that will be underplanting longleaf pine. So kind of tying into that multi-aged stand objective that a lot of landowners are interested in. That is going to be presented by Nathan Klaus and Joan Walker. So join us for another lunchtime webinar. You can also always find more topics like this on forestry webinars. If you scroll down to the front page, you can see a place here to subscribe, kind of hidden on that right-hand column, as well as all the upcoming webinars that are taking place that week. So there's always a lot of activity. You can subscribe and not miss a thing. Find some topics that apply to you. This session will be available back on the landing page here. It'll be available on demand for later viewing. That should take a couple days to about a week, so check back there. And again, here is where I've already linked a couple of related articles and sites, and I'll add those additional ones from the closing slide there. So you can always come back and find that. Thank you. Thank all of you for coming to join us today. And we'll leave things there. Hope to see you again.